When you stand under a dark sky, the view feels like a synchronized live broadcast, thousands of stars appearing exactly as they are right now. But that sense of a shared now is a trick of the senses. The deception is a matter of scale. Light moves at 186,000 miles per second, a speed that makes illumination feel instantaneous here on Earth. But the space it must cross to reach us is so vast that even light struggles to bridge the gaps. Astronomers measure these distances using the light year. This isn't a measurement of time, but of physical span, the 6 trillion miles a photon covers over the course of 365 days. Because light requires time to travel, it is physically impossible to see the present moment anywhere else in the universe. The farther we look, the deeper we fall into the past. Even our own sun is a delayed image. It takes roughly 8 minutes for its light to reach Earth. If the sun were to suddenly vanish, we would remain oblivious, basking in its warmth and light for 8 minutes after it was gone. We are out of sync with our own local star. Our perception of a unified present is flawed before we even look at the deep night sky. As we step past the edges of our solar system, that local delay of minutes quickly turns into years. Our absolute closest neighbors are the stars of the Alpha Centauri system, including the small red dwarf Proxima Centauri. They sit roughly 25 trillion miles away. Even at light speed, the journey takes so long that the glow we see from them tonight is already 4 years old. Measured just stepping into our immediate neighborhood shatters the concept of a universal present. We are looking at their history, and they are looking at ours. Moving deeper into the galaxy, we find the constellation Orion and its famous red supergiant, Betelgeuse, a star 700 light-years away. Betelgeuse is a volatile, dying monster. It is destined to eventually collapse under its own weight and trigger a massive supernova explosion. If that explosion happened today, the late news of the star's death would travel toward us for 7 centuries. We wouldn't see the flash until roughly the year 2700. This delay often leads to the assumption that the night sky is a graveyard, that most of the stars we see are already dead. But the stars visible to the naked eye are actually quite close and live for billions of years. Statistically, almost every star you can see without a telescope is still burning right now. The sky is a delayed broadcast, but it is a portrait of a living neighborhood, not a collection of cosmic ghosts. To see into the distant past, we built massive instruments on Earth's surface, isolated on high ridges to catch the faintest ancient light. These observatories require precise coordination from ground-based hubs, where scientists process data that has been in transit for millions of years. Orbital observatories like Hubble act as the ultimate time machines. Free from the interference of Earth's atmosphere, they capture light that has traveled from the very edges of the visible universe. When these instruments look toward the Andromeda galaxy, they are capturing photons that left their source 2.5 million years ago. Andromeda's light began its journey during the Paleolithic era. It has been traveling toward us since before modern humans existed. When we use telescopes to cross millions of light years, we aren't just doing physics, we are performing archaeology on the cosmos. By pushing our vision into infrared light, we can look past fully formed galaxies and into the deep unknown. This reveals red-shifted, distorted galaxies from billions of years ago, the universe as it looked during its chaotic infancy. To go even further, we built specialized spacecraft like WMAP, designed to look past the first stars and galaxies entirely. These probes detect the cosmic microwave background, a primordial afterglow frozen in time from just 375,000 years after the Big Bang. This radiation marks the absolute physical limit of our vision. It captures the transition from a hot, opaque plasma to a transparent universe, the earliest point from which light could finally move freely across space. When you look up at the night sky, you aren't seeing a single moment. The sky is a composite image, stitched together from vastly different eras of history. Your eyes are seeing light from 8 minutes ago, 4 years ago, and 2 million years ago, all at once. Because light speed is finite, a synchronized universal now is a scientific impossibility. every object in the sky is trapped in its own era. If every star and galaxy is just an old message arriving late, what does now actually mean when you look at the sky?